Welcome back. The objective of this video is to introduce decomposing functions. When you decompose a composite function, you're finding the components of the composition, or an inner function and an outer function. For each function h, find functions f of g such that h of x equals f of g of x. So g of x here will be our inner function, and f of x will be our outside function. So I look at something like h of x and I see x plus 3 is inside what would be x squared. So my inner function g of x would be x plus 3, and my outside function is x squared. So if I put x plus 3 into x squared, I would indeed get x plus 3 quantity squared. So in example B, I see my inner function, like x minus 5, has been put inside 1 over x. So x minus 5 is my inside function, and 1 over x is my outside function. Square root's pretty easy to see. We see x plus 2 is on the inside of our square root, or the square root of x. And in D, we see x minus 2 has been input here. We've seen this kind of thing when we do U substitution. So our inner might be x minus 2, and our outer would be x squared minus 4x plus 5. Where if we put x minus 2 in everywhere there's x, we would get h of x. In example 5, we'll let h of x equal the square root of 3x squared plus 1. We want to write h as a composition of functions in 2 different ways. I've actually done it in 3 different ways here. So our function h of x is going to be made up of f of g of x. So our inner function is g of x, our outer function is f of x, and that notation is important. So our inner function I see here, our inner function would be 3x squared plus 1, and an outer function of the square root of x. So if I put my inner into my outer, I do indeed get h of x. Another way to write that, I could have g of x just be x squared. So I'm putting x squared into the outer function of the square root of 3x plus 1. So another way to write that. And a third way you could look at this, you could say, well, I'm putting 3x squared, this whole thing could be my input into the square root of x plus 1. So our outer function is the square root of x plus 1, our inner function is 3x squared. And in example 6, we want to interpret this composite function. So we read here, Jim plants wheat on his farm in Kansas. The function w of a gives the amount of wheat in bushels that he expects to harvest if he plants acres of land. So he plants some land, or acres of land, and he's going to harvest bushels of wheat. When the wheat is harvested, he can calculate how much money he makes in dollars from selling the bushels. So the amount of money he makes depends on the number of bushels that he sells, but the number of bushels he produces depends on the number of acres he plants. So our inner function would be w of a, and our outer function is going to be m of w. The meaning of W5 equals 275, or WA equals 275, means that if he plants 5 acres of wheat, he will generate 275 bushels. So plant 5 acres, generates 275 bushels. Explaining the meaning of M65 equals 550, well, this means our input in M is the amount of bushels. So this would mean sell 65 bushels and earn $550. Explain the meaning of m of w of 4. Well, our inner function is our wheat function. So this means if we plant 4 acres, we're going to end up generating $2,100. So we plant 4 acres. In the end, after he harvests and then sells, we will generate $2,100 from the harvest. And there's a couple examples of decomposing functions and interpreting composite functions, and you'll get some more practice with this when I see you in class.